Welcome back to the deep dive. Today, we're going to be looking at data fitting, something that you flag as interesting. We've got some excerpts here from Open Educational Resources, Open Source Physics at Singapore,
Okay.
about a JavaScript simulation they've put together. And I have a feeling this is going to be a really eye-opening deep dive.
Yeah. What's fascinating is that we're not just talking about crunching numbers here, but we're looking at a real-world tool that makes data fitting interactive.
Right.
And it's all thanks to the amazing world of open educational resources.
Okay, so before we get ahead of ourselves, can we take a step back?
Sure.
When we talk about data fitting, what are we really trying to do?
Right.
I feel like I have a general idea, but I bet you can explain it way better.
Absolutely. Imagine you're a scientist with a table full of data points from an experiment. Data fitting is like finding the best fitting line through those points. A line that captures the overall trend, even if not every single point is perfectly on it. It's about uncovering the hidden relationship between the things you're measuring.
So, like, if I was tracking how many hours I sleep each night and how productive I am the next day, I could use data fitting to see if there's a connection.
Exactly. You could plot your data and see if a line, or maybe a curve, represents that pattern.
Okay.
Now, the classic way to do this is with something called least squares approximation, which sounds intimidating,
Yeah.
but it's actually pretty intuitive.
Full on least squares. I remember hearing that term back in school, but to be honest, it's a bit fuzzy now.
Think of it this way. Imagine each data point is connected to your line with a little spring.
Right.
Least squares like finding the line that makes the total tension in all those springs
Got it.
as small as possible. We're minimizing the overall error or distance between the line and the points.
Okay, that actually makes sense.
Huh.
I'm starting to see why this is so useful. Now, how does this JavaScript simulation we've got in the source material actually work? Does it show those springs and stuff?
It's even cooler than that.
Oh.
You actually get to plot points and manipulate a curve to try and fit it yourself. The simulation uses something called a polynomial function, which is basically a fancy way of saying you can create lines, curves, and even more complex shapes with it.
Wait, so I get to play around with it and see if I can find the best fit myself?
Yeah, yes.
That sounds way more engaging than just staring at a bunch of numbers.
Right. The simulation lets you tweak the different parts of that polynomial,
Okay.
seeing in real time how it affects the curve.
Right.
And the best part is there's a button you can press that reveals the true best fit calculated using that least squares method we talked about.
It's like a little competition between me and the computer. This is already blowing my mind.
Yeah.
So this website we're looking at, it's an example of what's called an open educational resource, or OER, right? Like,
Yes.
what exactly does that mean?
OERs are basically educational materials that are freely available for anyone to use and adapt. Think of them as textbooks, simulations, videos, and all sorts of learning content, but without the paywalls.
So this website we're looking at, Open Educational Resources, Open Source Physics at Singapore. It's kind of like a free library of science stuff.
Exactly.
Okay.
And the beauty of it is that anyone can access these resources, from students in classrooms to people learning on their own. It's a fantastic way to make education more accessible and equitable.
Okay, so we've got data fitting, we've got interactive simulations, we've got open educational resources. There's a lot going on here.
Yeah.
Now, there's one thing in the source material that caught my eye. They mentioned something called the NumericJS model element. What in the world is that?
That's a great question. While they don't go into too much detail, it sounds like it's the behind-the-scenes math whiz of the simulation.
Ooh, so like the engine under the hood?
Precisely. It's probably a library or tool that's handling all the complex calculations involved in finding that best fit curve using the least squares method.
Right.
You don't see it directly, but it's doing all the heavy lifting.
Wow, this seemingly simple simulation is suddenly sounding very high-tech. It's amazing to think that all this is happening behind the scenes while I'm just moving a curve around on a screen.
That's the power of well-designed educational tools, I think.
Yeah.
They make complex concepts accessible without sacrificing the underlying rigor.
And this brings us to another interesting part of the source.
Yes.
They have a section specifically for teachers
Right.
suggesting ways to use this simulation in the classroom. What did you find in there?
They had some really cool ideas. One suggestion was to have students experiment with the different parameters in the simulation to see how they affect the curve and the fit. It's a hands-on way to really understand the relationship between the math and the visual representation.
So instead of just memorizing formulas, they're actually getting to play with them
Yeah.
and see how they work in practice.
Yeah.
I bet that's much more engaging for students.
Absolutely. The source also suggests having students try to develop their own best fit algorithms. It's a more challenging task
Wow.
that really gets them thinking critically
Yeah.
about the process of data fitting.
Wow, so they're not just learning about data fitting, they're actually becoming mini data scientists.
Yeah.
I love that.
And that's the beauty of OERs. They can be used in so many different ways, from self-directed learning to structured classroom environments.
Right.
It really opens up a world of possibilities.
This is already so much more than I expected. We've gone from data fitting basics to interactive simulations to the power of OERs, and it feels like we're just scratching the surface. What else is in store for us in this deep dive?
Well, now that we've got a good foundation, I think it's time to take a closer look at the simulation itself. Let's walk through how it works and really get a feel for its capabilities.
That's good to me. Let's dive in.
You know, one thing that really strikes me about this simulation is that it doesn't shy away from the complexity of data fitting,
Right.
but it presents it in a way that's still easy to grasp.
It's true. Even I was getting a little intimidated when we started talking about least squares and polynomial functions.
Yeah.
But seeing it all come together in the simulation makes it much less abstract.
I think the key is that it's interactive.
Yeah.
And visual.
Uh-huh.
You're not just reading about equations, you're actually manipulating them and seeing the results in real time. It's learning by doing, which is always more effective.
And speaking of doing, if we were to actually walk through this simulation, what would that look like?
Okay.
I'm picturing myself as the user now.
All right.
Fingers hovering over the keyboard,
Yeah.
ready to fit some data.
All right, let's fire up the simulation. First things first, you'd input your data points,
Okay.
whatever they may be, sales figures, temperatures,
Yeah.
even the number of times your cat meows in a day.
Okay, so we've got our data plotted on the graph.
Right.
Now what? Do we just start randomly drawing lines through them?
Not quite. The simulation provides you with a starting polynomial function, remember. That's our line or curve or whatever shape we need to fit the data. The fun part is you get to adjust the parameters of that function.
Parameters. Okay, you're going to have to remind me what those are again. I was still getting the hang of all this data fitting lingo.
No worries. Think of parameters like the knobs and dials on a sound mixer.
Okay.
Each parameter controls a specific aspect of the function's shape.
Okay.
You can tweak them to make the curve steeper, flatter, wider, narrower, you name it.
So it's like I'm sculpting the curve to fit the data.
Yes.
This is starting to sound like an art project as much as a math problem.
There's definitely an element of creativity to it. You're trying to find the most elegant and accurate representation of the data.
Yeah.
And as you adjust those parameters, you'll see the curve respond in real time, getting closer to or further from your data points.
But how do I know if I've actually found the best fit? I mean, I might think my curve looks pretty good,
Right.
but is there a way to know for sure?
That's where the best fit button comes in, the one we mentioned earlier. Once you're happy with your attempt,
Okay.
you click that button, and the simulation will calculate the mathematically optimal solution
Right.
using the least squares method.
Ah, so it's like a reality check. I can compare my handmade curve to the one generated by the cold, hard logic of mathematics.
Exactly. And that comparison is where the real learning happens. You start to develop an intuition for what a good fit looks like
Right.
and how different types of data might require different types of curves.
You know, this whole process reminds me of those old school pin art toys. You press your hand into the pins,
Yes.
and they create an impression. Here, we're using a curve to make an impression of the data.
I love that analogy. It captures the essence of what we're doing.
Yeah.
Creating a representation that captures the shape and contours of the data, even if not every single point is perfectly aligned.
Okay, so we've walked through the simulation, we've fit some curves, we've even come up with some pretty cool analogies.
Yes.
But let's zoom out for a second.
Yeah.
Why does all this matter? What are the real-world implications of data fitting?
Oh, the applications are vast. Data fitting is a fundamental tool in so many fields. Think about it. Anytime you're trying to understand a trend, make a prediction, or test a hypothesis, you're essentially doing data fitting.
Give me some concrete examples. Where would we see data fitting in action in the real world?
Well, in finance, analysts use data fitting to model stock prices
Okay.
and make investment decisions. In climate science, researchers use it to analyze temperature trends and predict future climate scenarios.
So it's not just about fitting curves to graphs.
Right.
It's about extracting meaningful insights from data
Yes.
and using those insights to make informed decisions.
Precisely. Data fitting helps us move beyond simply observing data to actually understanding the underlying patterns and relationships.
Okay.
And once we understand those relationships, we can start to make predictions about the future.
Wow, this is way more powerful than I initially realized. I'm starting to see data fitting everywhere now.
Yeah.
It's like a secret code that unlocks the hidden language of the universe.
I love that way of looking at it. And with tools like this simulation,
Yeah.
that code is becoming more accessible than ever. That's the real power of open educational resources.
Right.
They empower anyone to become a data detective.
Okay, so we've established that data fitting is important,
Yes.
versatile,
Uh-huh.
and now, thanks to OERs, incredibly accessible. But I'm curious, are there any potential pitfalls or limitations to this technique?
That's a great question. It's important to remember that data fitting is a tool.
Yeah.
And like any tool that can be misused or misinterpreted,
Right.
one common pitfall is overfitting, where you create a curve that fits the existing data perfectly, but fails to generalize to new data.
So it's like making a suit that fits you perfectly today.
Yeah.
But if you gain or lose even a little weight,
Exactly.
it's no longer a good fit.
You need to find a balance between fitting the existing data well
Okay.
and creating a model that's robust and generalizable.
Are there other things we should be aware of when using data fitting? Any red flags to watch out for?
Another important consideration is the type of function you choose to represent your data.
Okay.
Sometimes a simple linear function is enough, but other times you might need a more complex polynomial or even an entirely different type of function. Choosing the right function is crucial for getting accurate and meaningful results.
This is not a one-size-fits-all approach. You
Yeah.
need to be thoughtful
Right.
about the tools and techniques you're using.
Absolutely. Data fitting is both an art and a science. It requires a combination of mathematical rigor and critical thinking.
This deep dive is really living up to its name. We've explored the theory, the practice, and even the potential pitfalls of data fitting. I feel like I've gained a whole new appreciation for this powerful technique.
I'm glad to hear that. But we're not done yet.
Oh.
There's one more crucial aspect of this discussion that we haven't touched on yet. The ethical considerations of data fitting.
Ooh, that sounds intriguing.
Yeah.
What kind of ethical dilemmas can arise from something as seemingly objective as fitting a curve to data?
Well, let's unpack that in the next part of our deep dive. It's a topic that deserves its own dedicated exploration.
All right, I'm all ears. Let's continue this fascinating journey into the world of data fitting. Okay, so we've talked about the how-tos and the why-fors of data fitting, but you just mentioned something about ethical considerations.
Right.
I'm really curious about this. Where does ethics come into play when we're just dealing with numbers and equations?
It's a great question. And it might seem counterintuitive,
Yeah.
but even in the seemingly objective world of data,
Right.
there's always a human element. The way we collect, interpret, and present data can have a significant impact
That's right.
on how it's understood and used.
So it's not just about the math, it's about the context in which that math is being used.
Precisely. Let's think about that simulation we were discussing.
Okay.
It's a fantastic tool for learning, but what if someone were to use a similar technique to manipulate data for their own benefit?
You mean like fudging the numbers to make a product seem more effective or a trend seem more pronounced than it actually is?
That's exactly the kind of ethical dilemma we need to be aware of. Data fitting can be used to illuminate the truth, but it can also be used to obscure it.
So how do we guard against that? How do we ensure that data fitting is being used responsibly and ethically?
One crucial aspect is transparency.
Okay.
When presenting data,
Yeah.
it's essential to be clear about the methods used, the assumptions made, and any potential limitations.
Right.
We need to give people the tools to critically evaluate the data for themselves.
It's like showing your work in math class. You need to demonstrate how you arrived at your answer so that others can verify your process.
That's a great analogy. And beyond transparency,
Yeah.
we also need to be mindful of the potential consequences of our data analysis.
Right.
Who might be affected by our findings.
Okay.
Are there any unintended biases baked into our data or our models?
So it's not just about getting the math right. It's about considering the broader social and ethical implications of our work.
Absolutely. Data fitting is a powerful tool,
Right.
and with great power comes great responsibility.
You know, this whole discussion has really shifted my perspective on data fitting.
Uh-huh.
I used to think of it as a purely technical skill, but now I see it as something much more nuanced and multifaceted.
I think that's a valuable takeaway from this deep dive.
Yeah.
Data fitting is not just about crunching numbers. It's about understanding the world, communicating our findings, and using that knowledge responsibly.
So for our listener, the person who wanted to learn more about data fitting,
Right.
what's the one key message they should take away from all of this?
I would say this. Data fitting is a powerful lens through which we can understand the world.
Oh,
But it's important to wield that lens with awareness, transparency, and a strong ethical compass. Don't just focus on the numbers. Think about the story those numbers are telling and the impact that story might have.
that's a powerful message. And what I find so inspiring is that thanks to open educational resources like the simulation we've been discussing, these tools and this knowledge are available to anyone who seeks them out.
It's truly remarkable. We live in an age where anyone with an internet connection can become a data scientist, a storyteller, an advocate. It's an exciting time to be exploring the world through the lens of data.
Well, this deep dive has been an incredible journey. We've explored the mechanics of data fitting, the power of open educational resources, and the ethical considerations that underpin it all. I feel like I've learned so much, and I hope our listener has too.
It's been a pleasure diving into this topic with you. I always enjoy exploring the intersection of data, technology, and human experience.
And to our listener, thank you for joining us on this deep dive. We encourage you to continue exploring the fascinating world of data fitting and to use this knowledge to make a positive impact on the world. Happy exploring.